Stepper motor connection. Hi friends. I offer you a practical algorithm on how to properly connect the windings of a stepper motor to the driver. Beginners, and not only, arduinists, when working with stepper motors, often face the problem of determining where the conclusions of the first winding are, where is the second, where is the beginning of the first winding, where is the second. The question often arises as to how to change the direction of rotation of the engine with wires. Let's see in this video how to approach these issues with a high degree of clarity. Let's subscribe to the channel, like this video and move on. In the ideal case, we may come across a well-known type of stepper motor, which has a standard fixed terminal block, the connection diagram of which is easy to find in Google Images. It is also desirable that there be an easily found connection diagram for the existing driver. Then they most often turn out to be connected the first time without errors. Although I managed to mess up in such cases. But we will proceed from the fact that we have an engine with an unknown color marking of wires, which often becomes a problem and there is no circuit for connecting the motor windings to the existing driver. By the way, about driver connection schemes, there are also factors of confusion and misunderstanding here. Here is an example of the designations of the outputs of the three most popular drivers. Circles will denote the conditional beginning of the motor winding. All the designations here are very different for each driver. These differences begin with the instructions themselves on the driver chips. Right in the PDF for each of these popular microcircuits, the creators have put so much confusion. How can you figure it out without a glass of beer? If possible, you should test the connection on an unloaded stepper motor. For control, we take the Arduino Nano controller. We will use it simply as a master generator. You can take any stepper motor driver. Just understand the documentation or the signatures on the board. Where are the pairs of outputs for each winding? I will take the most popular A4988 driver. Here is the switching circuit for our universal algorithm for connecting motor windings. From the controller, a square wave signal of a known frequency is fed to the input of the step driver, which is responsible for starting the steps. At the same time, the DIR input, which is responsible for the direction of rotation of the rotor, is connected to a common wire. We will not need it. Also, for a specific driver, it is necessary to supply power to the logic. For some drivers this is not necessary. And it is also necessary to give signals that allow rotation, such as reset, sleep, enable. For the A4988 driver, you can simply put a jumper between reset and sleep. This will put the driver into operating mode. We also connect the motor power wires to a 12-volt source. And we try to connect the motor coils according to the available diagrams and documentation, at least to our pairs of driver outputs. But, if you can't figure it out right away, don't despair, we will analyze all cases here. Now let's quickly turn our attention to the program that will be loaded into the Arduino Nano. I take the standard blink example, which blinks an LED once every 2 seconds, and assign my output number 2 to which the step input is connected. I also set the delay to 1 millisecond. This means that a square wave with a period of 2 milliseconds or 500 Hz will go to the input of the step driver, which for a 200-step motor corresponds to 2.5 revolutions per minute or 150 revolutions per minute. This speed is neither large nor small, and, as for me, is well suited for experiments on connecting motor windings. By the way, instead of the Arduino controller, you can do the same with a rectangular pulse generator. Set it to a frequency of approximately 500 Hz. The output voltage amplitude should be 5 volts. Connect the common wire and the generator output to the step input of the driver. So after connecting, you will get one of 4 situations. In the first, you will correctly guess the beginning of both coils. In the second case, one of the coils will be connected with the beginning in the opposite direction. In the third case, you will guess the beginning of the coils but mix up the pairs of driver outputs, and in the fourth case everything will be confused as much as possible. Now let's try all these cases in practice. In the first ideal case, the motor rotor rotates at the expected speed in the direction we expect. In the second case, we observe the usual rotation speed and normal operation of the engine. Only the rotation is directed in the other direction. In most cases, this will work for you. In the third case, we have mixed up the pairs of driver outputs and they do not match the outputs of their coil. The rotation is unpredictable, or rather jerking the rotor back and forth. In the fourth case, everything is repeated from the third experiment. Often such a connection confuses half of its work and it seems that everything is connected correctly, only the direction of one winding needs to be changed and that's it. In fact, it is so, but it is necessary to change the connection of not one winding, but two wires from different windings. And, in order to quickly change the direction of rotation of the rotor with the help of wires, I flip all four wires from the engine in a mirror. Once again, let's take a closer look in a graphical form, what needs to be turned over. Here, the letters A and B denote pairs of driver outputs. In the first case, everything suits us. In the second case, we will not like the default direction of rotation of the rotor. To turn in the right direction, you need to change the wires on one of the pairs of driver outputs. In the third case, the motor jerks in place, which means that you need to swap two wires from different pairs of driver outputs. In the fourth case, everything is the same as in the third, only we may not like the direction of rotation of the rotor after swapping two wires, and then we find ourselves in the second case and already know how to turn the rotor in the other direction. In general, no matter how we connect a stepper bipolar motor to a working driver, we get two options for events: either the rotor rotates in operating mode, or it twitches in place. And in order for it to stop twitching and rotate normally, you need to throw two wires. This is the algorithm for connecting a stepper motor. Thank you for your attention. Your subscription and like will help us a lot, and share the link to the video on social networks.